Well, hello guys, here Mr. G with another video after a short holiday. This time we're going to be talking or solving a question to determine the molecular formula of a compound. This is applicable for the grade 10, 11 and 12, but mostly for the grade 11. Now the question says analysis of a molecule show that it has a molar mass of 74 grams per mole and is 64,8 carbon, 13,62 hydrogen and 21,58% oxygen. Determine the molecular formula of the molecule. Now to determine the molecular formula, the first thing we have to do is to get the empirical formula. And to get the empirical formula, I personally like to do a table, but you do not have to. Now, in this table, I'm going to place the different atoms or elements that compose the molecule that we are talking about. So that is the first part. We have here, for instance, carbon, hydrogen, and oxygen. Then we are going to have a column in which we are going to place the percentage, just like the data. In this case, we have that is 64,8 for carbon, 64,8 for carbon. We have 13,62 for hydrogen, and we have 21,58 for this is the percent. I'm not going to write because it's on top on the column for oxygen. Then we are going to do the following. We assume that we're working with 100 grams, and if we're working in 100 grams, then out of 100, 64,8 grams will be for carbon, 13,62 will be for hydrogen, and 21,58 will be for oxygen. So it is the actual or the same one as the percentage, because we were considering now like if we have a sample of 100 grams. Now the next step, guys, is to calculate the number of moles, and we're going to calculate the number of moles for each of the mass divided by molar mass. So if you go to the periodic table to determine the molar mass of each of these atoms, you will get for carbon it's going to be 64,8 divided by the molar mass of carbon, which is 12. And in this case, you'll get 5,4 mole. If you go to hydrogen, same, you have 13,62 divided by the molar mass of hydrogen, which is 1, and then the answer is 13,62 mole. If you go to oxygen, you'll have that is 21,58 divided by oxygen, which is 16, and then the answer for oxygen is 1,35. And then what you are going to do at the end is to calculate the simplest ratio. And in the ratio, you are going to divide each of them by the smallest one. The smallest one is 1,3 out of the 3 calculations we done there, guys. So all we're going to do is divide each of them. For instance, 5,4 divided by 1,35. And you get that the answer is 4. And you repeat your process here for each of them. 13,62 divided by 1,35, and then here the answer is going to be 10, or let's say approximately 10, because it's 10,0 something. There we go. And the final one is 1,35 divided by 1,35, and the answer is 1. Guys, then after this one, we're just going to write the empirical formula. So the empirical formula is going to be carbon, and if you go there to the end, you have 4 for carbon, so it's carbon 4. For hydrogen, you go to hydrogen and you have a 10, so it's hydrogen 10, and then for oxygen you have a 1, so is oxygen 1. This one is the empirical formula. Now note the following. Empirical formula. Note the following. The question doesn't ask you for the empirical formula, it asks you for the molecular formula. Now, what we are going to do, we are going to calculate the molecular mass of the empirical formula. And you all should know how to calculate the molecular mass, but we're going to do it anyway. So the molecular mass for the empirical formula, we calculate in this one here, is going to be equal to 4 times the mass of carbon, which is 12, plus 10 times the mass of hydrogen, which is 1. When I'm talking about mass, I'm referring to the molar mass of hydrogen, plus 16. And you will get that is 74 grams per mole. Very simple. That is the molar mass of the empirical formula. We go back to the question and we're going to extract the molecular formula or the molar mass of the molecular formula. Alright, and we are going to divide the molar mass of the molecular formula by the molar mass of the empirical formula. So I'm going to write it like that. Molar mass of the molecular formula divided by the molar mass of the empirical formula. Alright, that's all you are going to do. You're going to divide those two. And if we do this one, we have the molar mass of the molecular formula is 74. So it's 74 divided by 74. That will give you 1. Okay, so we are going to do is multiply the 1 by each element within the empirical formula that we have there. In this case, 1 is quite simple, but it not necessarily have to be 1. Whatever number you get here, you multiply by each of the atoms there. So will be carbon, 4 times 1 is 4, hydrogen, which is 10 times 1 is 10, oxygen. So in this case, the molecular and the empirical formula are the same. This one is the molecular formula of the compound. And guys, that is all how to get the molecular formula. I hope you understand. I hope it helped. Thumb up, subscribe for the channel if you did, and then I'll see you next time with another question. Mr. G here.